Hi friends, welcome to my channel Easy Math Talks. So if you not yet like, share and subscribe my channel, please like, share and subscribe my channel. See, here we will discuss the topic is 10th class new syllabus. So chapter 1 real numbers. So what are the topics in the real numbers? We will discuss that one. So before the real number chapter, we will discuss the some basic concepts we learn. Okay. So what are those basic concepts we will see? First, what is digits? What are the natural numbers, whole numbers, integers, rational numbers, irrational numbers, real numbers, composite numbers, prime factorization. After you learn the basics, we will discuss the topic real numbers. Okay, we will see these basics. First one, digits. What is digits? Digits means numbers. What are the numbers? So 0 to 9. 0 to 9 means 0, 1, 2, 3, 4, 5 and 6, 7, 8, 9. So 0 to 9, these numbers are called as digits. Okay. Next, what is the natural numbers? What is the natural numbers? So natural numbers, the numbers which are counting means counting numbers are called natural numbers. Counting numbers. Counting numbers are called natural numbers. So these natural numbers denoted capital N. So that is we start 1, 2, 3, 4, 5 and so on. These are the natural number set. Okay. Here one is called smallest natural number. So here the greatest natural number does not exist. Does not exist. See here in this natural number set, we are involving here the even numbers and odd numbers. What are the even numbers? What are the even numbers? So even numbers which is defined the natural numbers which are exactly divisible by 2. Those numbers are called even numbers. So that even numbers which is denoted capital E. So 2, 4, 6, 8 and so on. These numbers are divisible by exactly divisible by 2. Those numbers are called even numbers. And next to odd numbers. What are the odd numbers? So odd numbers will define the natural numbers. So it is divisible by 2 and leaves the remainder. Means exactly divisible by 2 and leaves the remainder is 1. Those numbers are called odd numbers. So that is defined O is equal to set of 1, 3, 5, 7 and so on. These are the odd number set. Okay. So this is briefly about natural numbers. Next to whole numbers. What is whole numbers? So whole numbers will define those numbers means the numbers means natural numbers along with 0 is called as whole numbers. So natural numbers along with nat 0. So that is so it is denoted the letter is capital W set of 0, 1, 2, 3, 4, 5 and so on. This is the whole number set. Okay. So here the smallest whole number is 0. Greatest whole number does not exist. Okay. Next, what is integer? Integer will define the whole numbers along with negative numbers. So integers. So integers whole numbers along with whole numbers along with negative numbers. So it is denoted the letter capital I or Z. Z means Jahlan. Jahlan means count the numbers. So that set is and so on minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. So here the left side of the 0 is the negative integers, right side of the 0 is the positive integers. 0 is neither positive nor negative integer. Okay, next rational numbers. So rational numbers, so the numbers which is in the form of p by q. So which is denoted the letter q. Q means here the quotient numbers. So it is written in the form of p by q. Q not equal to 0. P comma q integers, and here the p and q are the co-primes. So co-prime means having only common factor other than no common factor other than 1. Okay. See, this is an rational numbers. For example, 1 by 2, 1 by 5, 0, 0 0.23, 0 0.5 and 1 0 by 1 minus 2 by 3. Okay, so these are the example for the rational numbers. Next, what is irrational number? Irrational numbers cannot be, the numbers cannot be written in the form of p by q. Cannot be written in the form of p by q. Those numbers are called irrational numbers. So here which is denoted the letter p or q dash. Those numbers are called irrational numbers. So here the, for example, irrational numbers root 2, root 3, root 5, root 7 and so on. So these are the irrational numbers which is cannot be written in the form p by q form. Those numbers are called irrational numbers. Next, what is real numbers? So this is our topic. See here the real number means here the both combination of the rational numbers and irrational numbers. Real numbers. So real numbers is denoted the letter R. So combination of rational and irrational. Rational and irrational. So R is equal to Q intersection. Sorry, Q union Q dash. So this combination of the rational and irrational is called as real numbers. So these are the examples. Real and rational and irrational numbers. Next, composite number. So here the our most important topic before the real numbers we discuss. That is composite number. What is composite number? What is composite number? The natural number having at least three factors. Those numbers are called composite number. So for example, so 4, 6, 8, 10 and so on. These are called as the composite numbers. So here 4, 6, 8, 10 and so on, those numbers are having at least three factors. That's why you are calling these numbers composite numbers. For example, you take one number 4. What are the factors of 4? 1, 2, 4. So these three factors of 4. That's why at least having at least three factors. That's why called composite numbers. And similarly 6. So 6, right? 2, 1, 2, 3, 6. So these are more than three factors. Means at least three factors. Those numbers are called composite numbers. See, next one, prime factorization method. See, prime factorization method. See, any natural number can be written as a product of its prime factors. Those method is called as a prime factorization method. So if we take any natural number, we will write in the form product of its prime factors. So we know that the prime numbers. So what are the prime numbers? We know that. So we know that prime numbers 2, 3, 5, 7, 11, 13, 17 and so on. So these are the prime numbers. So write in the prime factors, product of the prime factors, the given natural numbers, that method is called as prime factorization method. We will see the example. So 324, they write the division method or tree method. We will discuss. See here the division method I take here. So first you take two table. So 2 ones, 2 6 are 12, 2 twos, 2 eights, 2 ones. Next the 3 table. 3 twos are 6, 3 sevens, 3 nines, 3 threes, 3 ones. Okay, so I write here 324 is equal to 2 into 2 into 3 into 3 into 3. So here 2 square into 3 power 4. See here the product of prime factors. So the given natural number is 324. 324. So write in the product of prime factors. Here 2, 3 are the prime factors. So prime numbers 2 and 3. So this is a division method. We will see one more example. 189. See here. So here take the 3 table. 3 6 are 18. 3 3 are 9. So 3 twos, 3 ones. 3 sevens, 7 ones. So here 189 here right 3 into 3 into 3, 7. So 3 square, sorry 3 cube into 7 power 1. So here the product of primes 3 and 7. Product of primes 3 and 7. 3 and 7. So here 189 is a natural number. So that is our definition. So that is the method of prime factorization. Any natural number can be written as product of prime factors. So here the 324 is the natural number, write in the product of its factors 2 and 3. So here the 189 is the natural number. So right can be written as the product of prime factors 3 and 7. Okay, so this is the prime factorization method. So after we discuss the coming to the real numbers topics. So what are the topics? We will see that. See here the real number, some topics are there. See here the fundamental theorem of arithmetic, HCF, LCM, their relation between HCF and LCM. If P is a prime and P divides A square, then P divides A, when P is a positive integer. This is the theorem. So by using this theorem, you have to prove that the root 2, root 3 are the irrational numbers. So these are the main concepts of the real numbers. Okay, see here the first one, fundamental theorem of arithmetic. So what is theorem here? Every composite number can be expressed as a product of primes. Every composite number can be expressed as product of primes. This prime factorization is unique. Apart from the order in which prime factors occur. See, what is the meaning of this theorem? We know that the composite number. What is composite number? The natural numbers at least having at least 3 factors. Those numbers are called composite numbers. So these are the examples: 4, 6, 8, 10. These are the examples of the composite numbers. See, if you take any composite number, suppose I take a 4 composite number. So 2 into 2, I write here by factorization. So 2 into 2, suppose 6, 2 into 3, and 6 I write 3 into 2. Okay, and also take 8, 2 into 2 into 2. See here, if you take observe 6 right here 2 into 3 and 3 into 2. So what is the meaning of this one? Every composite number, take a 6 is a composite number, can be expressed as a product of primes. So product of primes 2 into 3 and 3 into 2. What is the meaning of this one? This is prime. This factorization is unique. So if you write like this, I write like this. So those are the same, means unique. That is the factorization is unique apart from the order. So order is this one is correct, this one also correct. So order is no need here order that apart from order, which is the prime factors occurs. Okay, so that is 2 into 3 or 3 into. Those are the unique. See one example. See here 24. I take 24. Write the by using factorization. See here 2 12s, 2 6, 2 3s, 3 1s. So how to write this one? 24 2 into 2 into 2 into 3. So here write here 2 cube into 3 power 1. See here 24 factorization. See here 3 8s, 2 2s, 2 2 4s, 2 2s, 2 1s. See here right here 24 is equal. So here 3 into 2 into 2 into 2. So here the order is here 2 cube into 3 power 1. See here, observe this example. 24 write the by using 5 factorization, write the factors 2 into 2 into 2 into 3. 2 cube into 3 power 1. So here the prime factor. See here this example. See here this one. I write here start with 3. So here the start with 2. So here the what is that meaning? That is the meaning. Product of primes. This factorization is unique. So both are same. So that is the apart from the order. That is the meaning of this theorem. So if you write this 24 here start with 2 or 3. So both are correct. That is the meaning of the product of primes. Every composite number can be expressed product of primes and this factorization is unique. So both two are the unique. So apart from the order. Okay. So in which the factors are occurs 2 3 here 2 3 are the prime factors. So this is the fundamental theorem of the prime factorization. See here. And next, so by using theorem, fundamental theorem of arithmetic, see this example, page number 8. So now textbook. Consider the numbers 4 power n, where n is natural number. Check whether there is any value of n for which 4 power n ends with the digit 0. See here, for any natural number, 4 power n ends with the digit is 0. We will see one example. Before that, ends with 0. So here write the factors, prime factors, 2 5s, 5 1s. So 10 is equal to 2 power 1, 5 power 1. See here take 50, 2 25s, 5 5s, 5 1s. So 50 is equal to 2 into 5 into 5. So 2 power 1, 5 power 2, 5 square. See here the ends with 0 numbers, very natural numbers. So here the 2 and 5 are the prime factors. Okay, see here the 4 power ends with digit 0. Check that one. Say right, if the numbers ends with digit 0, it should be divisible by 2 and 5 both. See here 4 power n is equal to 2 into 2 whole power n. So here the 5 is a not prime factor of 4 power n. See here 5 is not a prime factor of 4 power n. So hence 4 power n is not divisible by 5. So therefore 4 power n cannot be end with digit 0 for any natural number n. Okay, so this is the example for the fundamental theorem of arithmetic. You see, next topic, next concept here, HCF and LCM. We will see HCF. HCF means highest common factor. Highest common factor. See here, what is the definition of the highest common factor, HCF? The product of the smallest powers of each common factors in the numbers. See here, product of the smallest powers of each common factors in the numbers. We will see the one example. So this example in our textbook, page number 8. HCF of 620 by prime factorization method. See here, we have 6 factorization method. 2 3s are 6, 3 1s, and next 20. 2 10s, 2 5s, 5 1s. So here write 6 factors, prime factors 2 into 3, that is equal to 2 power 1, 3 power 1. And next to 20. 2 into 2 into 5. So that is equal to 2 power 2, 2 square, 5 power 1. See here the definition, product of the smallest powers of the each common prime factors. So here the right HCF of 6, 20 is equal to common prime factors. Common prime factors lowest powers means smallest powers. See here, observe this one. Common prime factors are, see here, common prime factors is of these two numbers. Common prime factor is only 2. Here the prime factors 2, 3, 5. Here but common prime factor is 2. Okay, next smallest powers in that number. See here, in the number. So in this number, in the common prime factor, smallest power is 1. So here write therefore HCF of HCF of 6, 20 is equal to 2 power 1. That is equal to, okay. So this is the highest common factor. We will find out the, so HCF of 6, 20 is 2. Next LCM. Next LCM. So LCM means what? Least common multiple. So what is your definition of the LCM? Product of the greatest powers of each prime factor. Greatest power of each prime factor involved in the number. Okay, we will see that one example. So this example 2, here page number 8 on our textbook question. So LCM of 6, 20 by prime factorization method. What is the LCM? See here we have, what are the prime factors here? 6, 2 3s, 3 1s, and 20, 2 10s, 2 5s, 5 1s. So factors are 2 into 3, so 2 power 1, 3 power 1, and 6 and 20 factors 2 into 2 into 5, 2 square into 5 power 1. See here the LCM, least common multiple of 6 comma 20 is equal to. So what is the definition here? Prime factors. Prime factors, greatest powers of each prime factor. So here the greatest powers of each prime factors involved in that numbers. See here the prime factors 2, 3, 5. 2, 3, 5. See here the greatest powers involved in that numbers. 2 greatest power is 2. 2 greatest power is 2. 3 greatest power is 1. 5 greatest power is 1. So here the LCM of 6 comma 20 is equal to 2 power 2 into 3 power 1 into 5 power 1. So that is equal to 2 square 4 into 3 into 5. So 3 5 are 15, 15 4 are 60. So LCM is equal to 60. Okay. So this is the definition. The product of the greatest powers of each prime factor involved in the number. So that is the least common multiple, LCM. Okay. And next, relation between HCF and LCM. See here completed this one, fundamental completed, HCF LCM completed. See here the if, this is theorem. So here the relation between HCF and LCM. See here, relation between HCF and LCM. If A and B are any two positive integers, how to find out the HCF relation between? So here the HCF of two positive numbers into LCM of two positive numbers is equal to product of numbers. So this is the formula. So they are given LCM of two numbers and product of two numbers given. Find out the HCF. Suppose product of two numbers and HCF is given. Find out the LCM. Okay. Suppose so you have to find out the HCF and LCM. HCF and LCM of the given two numbers. That is the relation between the HCF and LCM. See here, next theorem. If P is a prime and P divides A square, then P divides A where P is the positive integer. See here, let's take the P is a prime number. If P divides A square, P divides A and P is a positive integer. See how to prove this one. So this theorem are applicable. So apply in this, prove that the root 2, root 3 are the rational number. See here, how to prove this here? 2 divides 16. So here this 2 consider P, this 2 consider A square. Means 2 divides 4 square. And also 2 divides 4. That is the mean of the P divides A square. 2 divides 16. 2 divides 4 square. That is P divides A square. 2 divides 4. And we'll see this one more. 5 divides 25. So this is P. This is A square. So P divides A square. See here 5 divides 5 square. 5 divides 5. Okay. So this is a P divides P square, P divides A, where P is a positive integer. Positive integer. Okay. So this is about the theorem 1.2, page number 12 in our textbook. Okay. This is about the theorem. Next, we will see that example for this theorem. So we have to prove that root 2, root 3 are the irrational. We will see that next. See here. So I explained theorem 1.2. So by using that theorem, how to prove that root 2 is a irrational number. So this is a very most important question in the first chapter. See how to prove that root 2 is irrational. So let us consider root 2 is rational. First you have to assume root 2 is rational. Root 2 is rational. After that, you have to prove that root 2 is irrational. Okay. See, let us assume that root 2 is rational. Root 2 is rational. So here rational means what? Root 2 is equal to a by b. See here, b not equal to 0. A comma b belongs to integers. A and A and B are co-primes. Co-primes means have no common factors other than 1. See here, squaring on both sides. Squaring on both sides. Root 2 whole square is equal to a by b whole square. So here the square root cancel. That is equal to 2 is equal to a square by b square. See here, cross multiplication. 2b square is equal to a square. See here, this is the equation 1. See here, here 2 divides a square, then 2 divides a. 2 divides a. By theorem 1.2. 2 divides a square, then 2 divides a, means divisible. See, let take a is equal to 2c. See here, by 1, by 1, 2b square is equal to, in place of a square, I write 2c square. 2c square. What will happen? See here, 2b square is equal to 4c square. So here, b square is equal to 4c square by 2. 2 ones to 2 2s. That is equal to 2c square. So b square is equal to 2c square. This is equation. See here, 2 divides b square. Here 2 divides b square. 2 divide 2 divides b. So then what you conclude equation 1 and 2? Here the contradiction, here but this contradiction fact is a and b are the 2 is the common factor. 2 is the common factor. So but here the a and b here the root 2 is rational number. What is the rational number meaning here? Co-primes. A and b are the co-primes. Co-prime means so the numbers having the no common factor other than 1. Okay, so here but here in these two equations, so 2 is the common factor. See here, here 2 is the common factor of A and B, but this contradict but this contradicts fact that no common factors other than 1. So our assumption is false. So therefore root 2 is a irrational number. Okay, hence proof. Okay, so if you like my video, please like, share and subscribe my channel. Thank you.